Okay, so we want to look a little bit at what's called composition of functions. So I'm given a function here, g of x equals 4x cubed plus 1, and really embedded in this function are three separate functions, and order of operations matters here. The first thing we're going to do to our input x is cube it. After we cube it, we're going to take that output, what now is an output of x cubed, and we're then going to multiply by 4. Then we're going to take that as an input to another function, and we add 1. So our three functions here that we're looking at are the cubing function, quadrupling function, and the adding 1 function, and the order is important. We cube first, then we multiply by 4, and then we add 1. And for example, if I have an input of x going to x cubed, what was additionally an input, x, becomes an output x cubed, but then I'm going to take that output and use it as an input to then multiply by 4. And then I'm going to take that output, 4x cubed, and use it as an input and add 1. Okay, so note here, we've got our first function, which is our cubing function, and that's an h of x. Our cubing function we called h. So we're going to take our x and we're going to do h to it. That's cubes it. Then we've got that cube and we want to multiply it by 4. So that cube, that x cubed, becomes the input for f, right? Becomes the input for f, and f is our quadrupling. So we're doing f of an output h of x. We then are going to take that whole value, which is 4x cubed, and what do we want to do with it? We want to do c to it. We want to add 1. So our notation is c of f of h of x. And the other way I can write that is c circle f circle h of x. So another example. Suppose we have the function r of x, which is the cube root of x squared minus 7. Again, this rule r does a whole bunch of things, and the order is important. The first thing that r does is takes an input x and squares it. It then takes that x squared, which is now an output, x squared is an output of squaring x, and it then subtracts 7. So I've got a function, a squaring function, and then I've got a subtract 7 function. I then take that output of x squared minus 7, and it becomes cube rooted. So my three functions are squaring, subtracting 7, and cube rooting in that order. So if I wanted to express r of x in terms of f, g, and h of x, it would be r of x equals, what function am I doing first? I'm doing f of x first. I'm then using f of x as an output for g, and I'm then using g of f of x, the x squared minus 7, as an input for the cube rooting function, which is, we have said, is h. So it would be h of g of f of x, and in circle notation, h circle g circle f of x. So another topic in 4.2 is combinations of functions, adding functions, subtracting functions, multiplying functions, and dividing functions. And we can consider that from a point-by-point standpoint. Suppose you wanted to find f plus g of a. Basically what you're doing, that notation, is you're looking to find f of a plus g of a. So looking at what we've got set up here, at a, the value of f at a is 10, and the value of g of a is 8. So therefore, I would have f of a plus g of a equals 10 plus 8 equals 18. And I can see that simply what I'm doing, I'm taking a function value and output here, and then I'm adding another output here. So point by point, we could certainly look at seeing, visualizing what the function f plus g might look like. Where both function values are positive, clearly, my f plus g is going to be higher. Where one is positive and one's negative, well, it's going to be a little lower than the positive one, the highest positive one. And again, that's notation here is important. F plus g of a is simply f of a plus g of a.